Hi guys, welcome back to my YouTube channel. In the last video, we looked at how to build a design in the layout window. Now, what we need to do now is simulate that design that we built. So we need to first of all set up EM simulation and then simulate the design. Now, at the end of this particular video, I expect you guys to be able to set up EM simulation in ADS and of course define the dielectric and conductor materials. So we'll also be setting up substrate, and finally we should be able to simulate the design and then capture our results. So the results we're going to capture at the end should look like what we have here, and our substrate setup will follow the format you also have on your screen. So let's get started. I'm just going to go to the ADS to look at that design. So this is the design that we made in our last video. Please, if you did not, if you have not watched this video, my advice is that you go back to my channel and look for a video titled Basics of ADS Layout or Basics of Layout Design. So look at that video and then you should see the steps that we followed in order to come up with this design. So our task at this point is just to simulate this result, this design, and then get a result that we can say whether the design works or not. Looking at this design, you can see that this is a three-pole bandpass filter. So this is hairpin, one pole, this is the second pole, and that's the third pole. So we're using hairpin for this design. So the first thing I need to do here is to set up the conductor and the dielectric. Now for this design, I have chosen a particular substrate, which is the Rogers substrate, and with the substrate material having a dielectric constant of 10.7. That's what I've chosen. So we're going to set up all the parameters. Now, it doesn't matter which substrate you choose, you're all still going to go through the same design procedure. So the first thing I need to do is to go to options. You see where it has options here. If you go to options, you see where it says, let's go to where it says technology. So you go to options, technology, and then you see materials definition. So click on material definition. So here we are going to define the material that we're going to use for our simulation. So the first thing I'll do here is I can add material, I can add dielectric, I can also add from database. So I'm going to start with, let's start with dielectric. We can then do the conductor later. So start with dielectric. So let me go to database. Let's look from the database. I'm using Rogers 6010. So R2 Droid 6010. So go to RT. So if you see Rogers here, so RT Droid 6010. So that's the dielectric I'm using. So I'm going to click on that dielectric and say OK. Once I say OK, you notice that I now have the material included in my dielectric window. So I'm using 10.7 as the as the effective dielectric constant. So as the dielectric constant of the material. So I'm going to change this 10.2 to 10.7 to agree with what I'm using. Now the loss tangent is 0.0023, so that's correct. I'm not going to change that one. So everything looks okay for now. I'm just going to say apply. So that is done. Now for the conductor material, we do the same thing. Click on the conductor tab and then use the database. If I go to from database, I'm using copper. So let's go with copper. Click on copper here. Say OK. Now I have the copper assigned. Don't look at the layout design. So this is assigned to my layout design, which is the design that I have here. So my copper, my conductor and dielectric materials have been set. I'm going to say apply, and to close the window, I just say okay. So I've done the first step. I've set up my materials, both the conductor and the dielectric material. Moving forward, I have to after setting up the conductor and dielectric material. Next thing I will do is to set up my EM simulation. So to do that, you just go to the by. You see where you have, if you point at all of this, see where I have EM simulation settings. So it's right there. So if I click on EM simulation settings, I get this window, right? Now, this window, you don't need to do anything. Just click on create EM setup view. So click on that. Now that brings me to this view. On this view, you notice here that there's a yellow mark on the substrate. What that tells me is that the substrate is yet to be set up. If you look at the ports, you see that the ports are fine. I have port 1 and port 2. So that means the ports in my design is okay. So if I go back to my design, you see here's my design. That's port 1, that's port 2. So if I delete this port, you notice here that there will be a yellow mark here at the ports. But my ports are fine, so no yellow mark. My substrate has got yellow mark, meaning I'm yet to set up my substrate. You can see that there's no substrate here. Now the frequency plan is where I will set up the start frequency and the stop frequency for my simulation, meaning where I want to start and where I want to stop. If I go back to the design, I'm planning to start at 2.2 gigahertz and stop at 3.0 gigahertz. So that will be my the parameters I'll place at this point, 2.2 and 3.0. So I need adaptive simulation, adaptive. So I'm leaving that as it is. Now, the next thing I need to set up is the options. If I go to the options, I'll set up the mesh. I'll just click on edge mesh. So make sure you have this edge mesh. I can just do that now. Select edge mesh, and that is fine. Now I have to go back to all of these substrate frequency. I've set up options already, and I've also set up ports. So I now have to do my frequency and the substrate. So let me just do the frequency. So I now have only the substrate left. So I'm going to write type 2.2 gigahertz, and then I stop at 3.0 gigahertz. Now I have set up my frequency as well. The only thing left now is the substrate. So I will also set up my substrate. You can do that later if you want, or you can just all you need to do is just click on save. This diskette save your work, and you can go back and set up your substrate. So let me just do that. You can also do it from here. I'm just going to save for now. So you see here, so you can just say save anyway. So you've saved your substrate. Now, I can just go on this point here to open a substrate editor. You can also do that. I can close this window. You can also do that from here. You can also This is also your substrate editor, so you can also get it from here, or you can do it from your EM simulation settings. Okay, so let's just go from here. So here I'll just click on my substrate editor. He said no ADS substrate found, so I haven't created anyone, so no one is found yet. So I can just say okay. Now I have this substrate called substrate 1. I can leave it as substrate 1 as the name, that's fine. Here, I need to look at what I have here. I have alumina, all of this. So for now, I'm just going to leave it the way it is. I will set it up later. I'll leave it the way it is and just say create substrate. So this gives me the substrate window. This is the substrate window. So I need to make all my settings here. So the first thing I need to do is, remember we already set up the substrate material, which is Rogers CC10LM, and of course the conductor material. So we need to set up that material here. First thing I'll do here is to place a cover because remember we had that with guide box on the design, so we need to make sure that we contain our simulation within a particular space. So I'm going to put a cover here. So you just click on this top part and click on cover. So you notice now that you have a cover here. Now at the moment the cover is showing perfect conductor. I don't want it to be perfect conductor. I want it to be copper, as we already set up copper in our materials. So I'm just going to change this to copper here. Now if you did not set up define copper at the early stage, you will not find copper here. But because we've defined copper earlier on, that's why we have copper here. So I leave copper there. Now, based on the data sheet for my substrate, I have the thickness of my material as 35 microns. So I'm going to type 35 microns or micrometer. So I have micron here, is something as micrometer. So 35 microns. Don't forget, this um, data here depends on the substrate material you are using. So different substrate will have different thickness or the different size. So the thickness for this material I'm going to use is 35 microns. So I put that there. Now you notice that anytime you make a change, it appears here in the table. So this is the table that gives you all the settings that you've made here. Now, next thing I need to do is to look at this gap. I mean, between the cover and the conductor, the microstrip conductor. So that's the gap there. So this gap at the moment is air, which is fine. We normally set this to 10 millimeters. So I'm going to put it as 10 millimeters. So I'll change this to millimeters. Excellent. So that's the gap. So you need to have that space of 10 millimeters for optimum simulation. So it doesn't have to be 10, but to get optimum simulation, I encourage you to use 10 millimeters. Now, once I've done that setting, that's fine. The next thing I'm just going from top to bottom. The next thing I need to set up is the conductor, which is the microstrip itself. So this is this conductor here represents, I'll show you from my design, it represents conductor material on this microstrip layout, okay? So that's what we need to do. So here, again, I want it to be copper. I have perfect conductor at the moment, so I'm going to change it to copper. Now, perfect conductor means no losses, but we know that in real life you can't have a conductor without losses. So, for us to be able to have something that is as close as possible to reality, we use copper. By the time we fabricate our design, we can see that the result should be able to match our experimentation and simulation. So, I put copper there. No need to change the name of the conductor layer. So we'll leave it as conv1, that's fine. So that is done. Notice here now that it has changed from perfect conductor to copper. So I have copper, air copper, that's fine. Now that is gone. The next thing is to click on the actual substrate. That's the substrate. The gray part here is substrate. Click on the substrate. If you recall, at the start, we changed our substrate. So this is the substrate here. Remember that the substrate was we set it up. We defined it as Rogers R2 Duroid. So we click on this bit here, and then we go here and change this from alumina to Rogers. So which is what we defined at the start of this exercise. So now we have our substrate material as Rogers, okay? Now, and the thickness again is 35 microns. So I changed it to 35 um, microns or micrometer. So I have microns, that's correct. So my copper conductor all have 35 microns. All the coppers you see in this substrate, make sure that each one is defined as 35 microns. Okay, so I have now 35 microns here. Now the last one is the ground. This is the ground plane, which is the ground plane means the back of your design at because don't forget the microstrip is in the middle of on the top of the substrate, the ground plane. Now for my ground plane, again, I change this to conductor. a copper conductor instead of perfect conductor. And again, I change this to 35 micron. Now you can see I've now fully set up the substrate. All I need to do now is click on save. If I save this, now one last thing, I think I missed out one last thing. On the substrate thickness, I know I clicked on it, but I haven't set up the thickness of the substrate. So I did put 35 microns here, but this is a substrate, not conductor, so it's not 35 microns. Sorry about that. This is actually meant to be 1.27. 1.27. Again, this comes from data sheet, 1.27 millimeters. So this should be 1.27. Only the conductors are 35 microns. This is a conductor, that's a conductor, and that's a conductor. So 35 microns each. For the substrate, the thickness is 1.27 millimeters. Now, having done all of that, you can see here that I have all my settings. I can still see there's a copper here with 0 micron. That's not correct. We need it to be 35, just like that and that. So I'll go here and change this thickness to 35 microns. Now they all look perfect now. I have 35 micron for copper, 35, 1.27 for dielectric, and then 10 millimeters for the space. Okay, excellent. That looks good. I'm just going to click save. You can close this window now. So if I go back to my ADS, to my layout window, if I now click on EM, let's check it out. Click on EM settings, you notice that the yellow mark is now gone because we now have our substrate set up. So the yellow mark is gone. Excellent. So we can now close this window again. Do you want to save? Yes, I want to save and close. So I've done everything I need to do. And anytime you see an asterisk, it means design is not safe. So I'm going to click save. So the next thing is for me to run my simulation because I've been able to set up the simulation. The final step is for me to run my simulation. To do that, all I just need to do is click on the gear button here. So if I start EM simulation, I click on that. The simulation should run. If there's any problem, you have the status message here, or if anything is not right with the simulation. But for now, it looks like everything is going fine. That's good. So I have my results. I can plot my graph here. So I can just plot my graph. So I have my S21 and S11. Okay. So you can see here that this is what we got at the start. Now, this is actually my simulation result. I can just make this thicker if I like. I change this to 1.0 to make it thicker, nothing more than that. I can change this also to 1.0, 1.0. So now so you can clearly I have a filter, but of course, you don't expect it to be perfect at the first go. So what we need to do is to make some minor changes. You can make changes. I can save this for now, close this window, and close that window. So now I have my design. I um I have the result as well. If I can close this window if I like. Close this window. If I go back to the results here, you can see the result is there. And here is the substrate editor. You can click on it if you want to modify. It's actually there. And the EM setup is also there. So everything is now showing on my workspace. I can close this. So if I need to make any changes, I can access it from here and make changes. Okay, so that's fine. Now, your result may not come up the way you want it the first time. So you are allowed to make changes to achieve your result. So what do we change? Go back to my layout. You may don't forget this design is symmetrical about the center of this resonator. So what it means is that if you need to change the height of this, make sure you also change the corresponding distance from here. So to make sure that you are not changing the balance of the symmetry. So what I need to do here is for us to see what happens. Let's just make some minor changes and see what happens. If I decide to, for example, um, reduce, this is actually 10.8. Let me try and make it, let me make it a bit smaller. So if I, maybe smaller, if I make it 10.7, let's make it 10.7 for example, and I make this one, if I make this 10.7, for the symmetry, I need to also make this 10.7. So let's say 10.7. Okay, so these are the, I mean, these are the things you can change to see how it will affect your result. So I have my result. I just keep it open. That's my original result. So if I simulate again, I'll see what the modifications I've made will cost. So I just go and simulate one more time. Yes, so this is to overwrite. I say yes, overwrite. Let's watch the result. What happens? Okay, you can see there's a change. So it's getting better because you can see my 20 dB return loss is there. So it's actually getting better. You can keep making changes until you achieve what you are looking for. So I can see there's a positive change. That means I may just go back there and try and make it maybe 10.6, maybe 10.6. Make sure you do the same here, 10.6. I simulate again. So, I mean, you just have to keep making changes until you achieve something close to, because our design was for 2.6 center frequency. So we try to see if we can get close to that. Okay, so you see here where it actually got a bit worse. So anyway, what I'm saying here is that you can make changes until you achieve the target that you aim to achieve. So I see that um, um, I see that 10.6 didn't look well, so I can make it 10.65. So I increase it a bit and make this one 10.65. 10.65. Now, this is going to be my last change. I'm not going to keep changing it, but you understand what I've just said. So all you need to do is to try making some change. You can also change this limb. But once you change the size of this limb, make sure you also change the size of that limb, okay? Just to make sure that you are keeping it the same. So I go back and simulate, and I'm going to see how that affects my result one last time. Okay, so that's what I have. All right, so we can make as many changes as we like until we achieve our target result. So, but I'm not going to continue with this in order not to unnecessarily prolong the video. So just keep making changes until you achieve what you want. Now, this is basically where I can save my result now. I'll close this window and also close this window. And we have come to the end of this activity. So you can see how you can build your circuit, simulate, and achieve any results that you desire. So one last thing I would like to say is just a reminder that you should be able to subscribe to this channel so you can get all the update videos that I will be sharing to help you with your bandpass filter design task. Yeah. Thank you for listening to this, and I hope you've learned something new. And let's hope we'll have more videos to help you in develop your studies. Thank you, and bye bye for now.